Hello student, already I uploaded, or I can say I was online. I started fluid statics. Yesterday lecture was fundamental. I explained like volume, density mixture, definition of fluid. So in today lecture students, now I am going to give you V6 few numerical based on study class, right? So have a look students, this is question number 1, example based on study lecture. What's the questions? When equal volumes of two substances are mixed, the specific gravity of the mixture is 4, right student? Okay, that is students, you can do underline on this point. What says equal volumes? So students, you have to remember of yesterday class cases number 2, if you remember, as I said. Now students, let's continue reading the questions. When equal weights of the same mixture is 3, okay, equal weights of the same mixture is what students? You can say 3. Now students, equal weight of the same mixture substances, the specific gravity of the mixture. Same mixture is what student? There is something. Students, you can add. This is basically specific gravity of equal weight. For equal weight, my dear, what is the specific gravity? 3. The specific gravity of two substances could be, okay, fine, that is option students. So now I'm going to start solution of this question. Students, know as usual, Vicky sir solve any question step by step so that you can easily understand. So in step 1, what says V1 is equals to V2. Students, maybe not much visible. V1 is equals to V2 is equals to V. Then student mention specific gravity, that is 4. Student, it's a given data which I'm writing here, right? Now students, you can say in second case, what weight? Nothing, it's mg. So you can take a student, this is what basically m1 is equals to m2 is equals to n. For this case student, the specific gravity is mentioned, this is what 3. So students, here I'm going to use a strategy which I gave the formula. So now students, is step 2, further solution of these questions, right my dear? So first I'll use this concept. You know what is specific gravity? It's a what? A ratio of density, right? So students, here I'll use case 2 result. If you remember, density of mixture is equals to what my dear? This is density of rho 1 plus rho 2 by 2. I explained yesterday how it came, right? Go and watch that lecture. So density mixture students, here mentioned in the question how much? That is 4 is equals to rho 1 plus rho 2 by 2. So finally student, you got one result. You can say rho 1 plus rho 2 is equals to 8. Say equations number 1 my dear. Now students, I'm going to just solve this is further part. You can say it's step 3, right my dear? Okay, in step 3 beta, what they mention, mass is same, so I'll use case 1 density mixture result. My dear, density mixture result, what I gave yesterday, if you remember, this is twice times rho 1 into, my dear, this is twice times rho 1 rho 2 upon beta g rho 1 plus rho 2. I hope you understand this result. Students, for this case, what mentioned density mixture, that is what? Density mixture is nothing, it's about specific gravity basically, right? Now you can say this is 3 is equals to twice times rho 1 into what my dear? Rho 1 into rho 2. Rho 1 plus rho 2 students already be found from equation 1. So I am feeding this value over here. So what we can say, this is what 8. So you can write student for further calculation. This is what my warrior. This is step 4 for calculation of this part. For calculation of this part, my dear. Now students, you can say this is what twice times row 1 row 2 is equals to 24, right? Students, just do one thing. Again you have to use equation number 1, right? So from equation 1, my dear, I'm writing here row 2 is equals to 8 times of row 1, and this, let us suppose this is equations number 2, my dear. So this row 2 I feed over here, right? So what will get, student? Twice row 1 remains constant, right? Row 2 is what, student? I'm feeding this value over here only. So this is 8 times of what you can say, my dear, row 1 is equals to 24. Now just multiply, students, and open the bracket. You can see 8 to the 16 row 1 minus 2 row 1 square is equals to 24. Students, here you will get quadratic, right? So what you can say, twice of row 1 square minus, student, 16 times of row 1 minus 24. Student, this is left right only, right? Is equals to 0. So how we'll get row 1? For getting row 1, students, I'm going to turn the page, right? You can take snapshot. Once, students, you can take snapshot. Okay, fine. Now students, for that part I can solve. So you can see this is step 5. This is what, my dear? This is, you can say, step 5, student. That is what's the equations? Twice row 1 square minus 16 row 1 minus 24 is equals to 0, right, student? So here, row 1 is equals to, I'm just applying formula of x. X is equals to minus b plus minus root of d by 2a. So here, students, d is what, my dear? b square minus 4ac. So students, you can just compare this equation from quadratic, students. You will easily get the answer. Ax square plus bx plus c is equals to 0, right here. So you can see from here, a is equals to 2 and b, my dear, minus 16, and c is equals to minus 24. Now students, what's the formula of row 1? Minus v. So minus 16 already over there. So minus gets plus minus, my dear. This is what root of, just I'll calculate here, students. So 16 are what, you can see, this is 256 minus 4. Students, a is what, you can say 2, and minus this is what, 24. So you will get it as a 256 plus 4 to the 8, and 8 into what, beta? This is what, 24. So finally we'll get from here, this is 256 plus 8 for the 32, 8 for the 32, and 8 to the 16 and 3. How you can say 16 and 3, this is 192. So d beta, what you will get? This is 6 plus 2 8, 9 plus 5 14, and this is 14 4, and 2 1 3. This is what, 4 4 8, right? So you can fit over there 4 4 8 upon what, student? This is 2a. So you can see 2 2 ja 4. Now student, just further you can solve. Row 1 value will get from here. Row 1 will get, there are two values, row 1 plus and minus. you can take only plus only. So further solve beta, you will get that is rho 1 is equals to 6 and beta is rho 2 is equals to 2. So what is your correct options according to this? Again go back and just turn the page. Students, you can say 6 and 2 now. Hence students, your option first is correct. I hope you understand, right student? Okay, take snapshot. So now this is all about, I can say, study class. So study class example, actually at a study I was busy, so I couldn't continue, I can say continue classes more than 1 hour. But now that's a, I gave today numerical based on this. So now onwards students, I'm going to start your class as a should. What's the concept? Which is study I left remaining concept, right student? So here I can say for the things, for this is student first things, what is the topic which I'm going to discuss? Effect of, my dear, effect of temperature, effect of temperature on density. What is student? On density. It's a very useful concept. Literally student, it's a very useful concept. Now students, what is the things which you can analyze? Students, as the temperature of a liquid is increased. What is student? As the temperature of a liquid is, what you can see, increased. As the temperature of liquid is increased, then beta, what you can say, the mass remains the same, my dear. Mass remains the same while the volume, what is student? While the volume is increased. While the volume is, student, increased, and hence my student, the density of liquid, what my dear? Density of liquid decreases. Density of liquid, what you can see, decreases. Yes, as you know, everyone, according to yesterday definition, as I said, density is equals to mass per unit volume, my dear. So what you can see over here, density is inversely proportional to volume. Why I'm not considering mass? Because you know what is, if temperature of liquid, students, if temperature of liquid increases, then students, what you can say, volume of liquid increases and density got decreases. Why? Because density inversely proportional to volume. Density inversely proportional to volume. So here student, I'm going to explaining first what is the volume expansion. Right students, I can see that is a part not relevant over here, but you know BK sir never believed to give straightforward formula. Due to this students, first I'll discuss what is the volume expansion, right? So just student, take a snapshot. I'm going to turn the page, right my dear? Okay, fine. Now students, I can see for this condition. So first I'll discuss, students, first I'll discuss volume expansion. What my dear? First I'll discuss volume expansion, right? Students, for volume expansion, what is the things I can say which I wanted to discuss? That is, students, for volume expansion, let us suppose here I'm considering a cuboid. Students, here I'm considering a cuboid, right? And you can say students, now it's there is a cuboid, right? But you know, in cuboid there is length, breadth, and what? Height, everything, students, right? Okay, fine. So students, here I'm calling, let us suppose this is the length. Students, this is nothing but, you can see, this is the breadth, my dear. This is what? Height, right? This is the initial condition without rising or before rising temperature of this cuboid, right? If let us suppose, you can indicate, my dear, this is x, this is y, this is z. If you are going to increase the temperature, then what you can analyze, students? Initial volume, students, initial volume, I'm considering V, and what is V? LVH, right? So it's initial volume. Now students, you started to just rise the temperature, you started to increase the what? Temperature. Arrow mark with a what? You can see temperature increase. Temperature increases, right? Then you can see initial temperature is T. So final is what? T plus little change, dt only. So you can write also expression of volume, my dear, right? So what you can write? Volume V plus dV. There is little change, no? Okay, fine. Now students, here you can use the formula of this is dV by V. It's what, my dear? This is, you can say, fraction change in my dear. This is what? Volume, right? No, student, this is the fraction change in volume due to what? Change in temperature, right, my dear? So you can say dV by V directly proportional to dt, right? Okay, now students, you know, if you are getting some proportional sign, so you have to remove this one and use what? Some suitable constants. So here students, I'm going to write dV by V gamma times of dt, where gamma is what, students? You can say cubical expansion coefficient. What, student? This is, or you can say volume expansion, my dear, coefficient. Volume expansion coefficient. Now students, integrate both sides. Integrate both sides, my dear. So what's the changes over here? You can see initial volume, I'm calling V1, right? This is initial volume, student, it's a V1. Final volume, either you can say V2 or V. Here I'm considering initial volume is V1, student. Final volume is V2. Initial temperature, students, I'm considering here T1. Final temperature, students, here I'm considering T2. Right, my dear? Okay, so I hope all of you remember integration of dx upon x. What I can see, my dear? Ln x plus c, because it's indefinite. I hope all of you remember this result. Right, my dear? Okay, students, I can say, my dear, for this further, this is, you can write ln of v, and what's the limit, students? You can say v1 to v2, and this is nothing but gamma into delta t, and what's the limit? T1 to t2, my dear. Now, students, here just apply the limit. All of you know how can apply the limit. Upper, just replace the variable first time. So you can say upper limit minus, student, this is what? Lower limit. How can we apply the limit? You have to replace the limit to variable. First time this is the upper limit, this is what, my dear? Lower limit. So here you can write ln of v2 minus, student, ln of v1 is equals to gamma times t2 minus t1. Okay, students, here I'm going to apply one formula of log ln m minus ln n. Maybe all of you remember, because I'm writing everything. You are not in front of me. That's why. So this is what, my dear? Ln of m upon n. So students, this formula I'll apply, right? This formula, my dear, I'll apply. So what I can write? Ln of what, my dear? Ln of v2 upon v1. Del t2 minus t1 is nothing but, right? You can take, students, delta t as usual. So you can say gamma into delta t. Students, you can take snapshot. I want you to turn the page because it's over, right, students? Okay, I hope you already taken. So now, students, I'm going to turn the page. Okay, so what's this one? Just I'll continue same thing, right, my dear? So here you can say, what's the last result, my dear? Ln of v2 by v1 is equals to gamma times of delta t. Student, take anti-log my dear, both sides. Okay, so now, students, what you can say, if you are taking anti-log, so ln is what? Removed. Students, v2 by v1, ln base is e and log base 10. So this way, this is a property, students, into gamma delta t. Into what, my dear? Gamma delta t. So here I can write v2 is equals to v1 e to the power gamma delta t. So I can also derive this result by easiest method. But why I said? Because this kind of result is literally deserving for advance. So my class is trying to, you can say, curate both segment, main as well as advanced, right? Now, students, here I'm going to apply, there is what? Basics formula. What, students? I'm applying here expansion of e to the power x. What, students? Here I'm going to apply, there is one formula of mathematics, expansion of e to the power x. So what's the formula, my dear? This is 1 plus x. No, because this formula I can apply over here. So students, I can write v2 is equals to v1, what, my dear? 1 plus gamma delta t. So literally, my dear, it's a a very useful result. If you will raise the temperature, then how volume change of cubical body, right? Now student, but this is not our segment. Our segment to what, students, if you remember, our segment is what I can say, effect of temperature on density. Students, basically we are looking temperature and density relation, I can say, not this relation. Then beta, from here onwards, right, students, I wanted to tell you some extra information, right? That is what, students, you can say relation between, students, alpha, beta and gamma. Students, it's highly important, so just keep in your mind. Students, alpha is what? Coefficient of linear expansion. Beta, my dear, coefficient of you can see areal expansion or superficial expansion. And gamma is what? Coefficient of volume expansion. So this is alpha is to 2 alpha is to 3 alpha. So students, alpha itself alpha only. Students, beta you can write it's 2 alpha, my dear. Gamma you can write 3 alpha, right? Now you can see, student, this is what cancel each other. So now onwards, keep in your mind, ratio of alpha is to beta is to gamma. Alpha is to beta is to gamma is what, my dear? Alpha is to beta is to gamma is 1 is to 2 is to 3, right? So keep in your mind, it's literally highly important, my dear. Okay, so now rewrite this expression of V2. VT you can write, my dear, V1 1 plus 3 alpha delta t. So students, keep in your mind, this all result highly important for any kinds of competitive examination, right? Now I shall discuss variation of density with temperature. Student, now I shall discuss density of, you can say, density variation with temperature, my dear, right? Actually this is our basic agenda. Now students, study, I see this formula. Density is equals to mass per unit volume, right? So students, here I'll write first, I'll use this pen here because it's more visible for you. Rho 1 is what, students? M upon V1. As you know, this is the first thing which I starting point I said, discussion of this point, you will increase the temperature, then volume will increase, density will decrease, mass remains constant. So students, here I'm not writing M1, here I'm writing M. So let us say this is what, my dear, equations number 2. Now students, you can see rho 2, this is masses remain same, M upon V2, see equations number 2, right? Just take, students, ratio of rho 2 by rho 1. You can see, you have to just divide second by first. So what, my dear? Rho 2 by rho 1, you will get V1 by V2. Students, you'll get rho 2 by rho 1 is equals to what, my dear? V1 by V2. Very nice. Now students, because already we found V2. What is the V2 result, students? If you remember, otherwise I'm writing V2 is what? V1 1 plus gamma delta t. Just now, student, I derived. Just now I derived, my dear. Okay, so you can say rho 2 upon rho 1 V1 V2. Students, I'll put this value over here. This is V1, my dear, 1 plus gamma delta t. You can say this V1 cancel each other. So you will get, students, rho 2 expression of density in terms of you can say, student, what this is in terms of density if you are increasing the temperature. Here, students, again I'm just telling you for your better clarification, m1 is equals to m2, which is equals to m, right, my dear? So you can see rho 2 is equals to rho 1 upon 1 plus gamma delta t. So now, dear, you got density relation with respect to what? Temperature. After this, students, what I can conclude, right? Student, that is a conclusion. It's literally highly important, and it's a possibility they can ask as a theory questions anywhere. So students, keep in your mind, right? So what's the conclusion, student? What's the, you can say, conclusion for this case? If, student, you will raise temperature, I'm writing in short, all of you know how we can to write in short word, temperature increases, then, student, what you can say, length also increases. I'll discuss this one, how length increases in thermal properties of matter. Now, students, if length increases, then what you can say, my dear sir, area will be also change. Okay, if area will be changed, then what you can say, my dear sir, volume also will be changed, also will increase, right? Then what you can say, finally, density, what, my dear, density decreases. So student, this conclusion, keep in your mind, will help you to answer any basic questions, right? Students, now this is all about, I can say, density variation with respect to temperature. Now I'm going to give you very basics example based on this. Take snapshot, students, take snapshot, take snapshot, because I wanted to turn the page. Okay, maybe already taken. So now, students, I'm going to just move on next slide. On the page, slide is, it's the habit, students, right? Okay, so here it is. What's the question here? Have a look at the question first. Student, density of gold is 19.30 gram per centimeter cube at students 20 degrees Celsius. We'll stop. Compute the density of gold. Compute the density of gold at what, my dear? 90 degrees Celsius by adding what, my dear? By adding steam to it. You know, there is some source, students. So how rising temperature? By adding steam to it. I hope you got the I can say questions, so no need just more explanation. Okay, now students, have a look at the solutions, right? You can try. I'm giving you 30 seconds. You can try these questions. Not 30 seconds, I'm giving you 20 seconds. You can try once. You can try once. Pause the screen, try once. Okay, now I'm going to solve this question, right, students? Pause the screen, try first yourself, then you can watch my solution. Now students, as I'm going to use the, I can say step 1, what's the initial density? You can call rho 1 of gold. How much? 19.30 gram per centimeter cube. What's the temperature, student, over here? That is, you can write 20 degrees Celsius. You have to find rho 2 if temperature T2 becomes how much? This is what, student? 90 degrees Celsius. I'm facing a student, there is some data required here, right? So alpha missing over here. Alpha, you can write, students, 14.2 10 to the power minus 6 per degree Celsius. Students, I said I can say yesterday videos when I was making solution of J means, be remember SI unit of, you can say, alpha. Definitely will get one question in J means 2026. So students, step 1 finished. Now I'm going to start for the solution of this question. Step 2. So what is, students? You can say rho 2 by rho 1. Just now I derived, my dear, just now I derived this result. Rho 2 by rho 1. You can also write, my dear, this is rho 2 by rho 1 is equals to 1 upon beta 1 plus gamma delta t. So students, I use this result solution of this one. Okay, so this is what, my dear, this is 1 upon 1 plus gamma delta t. So students, rho 2 upon rho 1 upon what's a 1 gamma is, already I said, my dear, it's a 3 alpha. So 3 alpha, and what's the delta t, students? It's nothing but T2 minus T1. So delta T, correct. No need to convert in Kelvin answer because this is in degrees Celsius. Just match the answer like this. Then beta, what you can say, delta T, what you will get, that is 70 degrees Celsius. Simple, my dear. 90 minus 20, you will get 70 only. Okay. Now students, you can see 3 alpha is what? 14.2, and this is what? 70 degrees Celsius. Don't forget, write complete, my dear. 10 to the power minus 6. Okay. Now students, you can say, sir, we wish to find rho 2. Rho 2 is equals to rho 1 upon 1 plus, you can write 3 into 14.2 into 70 into 10 to the power minus 6. Students, rho 2, rho 1 how much? You can write 19.30. You can write, student, this is what? 19.30 upon beta g, what? You can say this is 1 plus 3 14.2 into 70 into what, my dear? 10 to the power minus 6. Student, for further solution here, just I am going to take left and right. So students, rho 2 is equals to 19.30. This entire term, student, goes up. So what you can write? 1 plus 3 14.2 into 70 10 to the power minus 6 to the power minus 1. Students, here I'll use the formula here for binomial expansion, right, students? So what? 1 plus x to the power minus n. What you can write? 1 minus nx. So student, this is the format, this is remain same. So I'll apply here binomial expansion. Take snapshot, student. I wanted to turn the page, right? Okay, I hope you've taken. So now I'm going to turn the page. Now students, here I can write this is rho 2 is equals to 19 point, how much student? 19.30. 19.30. 1 minus 3 student, no, because you know this is the formula I'll apply. 1 minus 3 into what students? 14.2 into 70 10 to the power minus 6, right student? So further just you can solve student. This is rho 2 19.30. 1 minus this is what you can say 70 into 3 210. So I'm writing only 21 into 14.2 into what beta? 10 to the power minus 5. One just mentioning over here, adjusting. Now beta you can say rho 2 is equals to this is 19.30. 1 minus now student, here we can just do further calculation here, right? 21 into 14.0 beta, how much I can write? You can do 21 into what? 14.2. So this is students, you can say 1 2 are 2 and 14 this is remains 14. 2 2 are 4 and this is what? 28. So 2, this is 4 4 8. 8 1 9, this is 2, how much? 1 decimal. You can see this is what? 298.2 into what beta ji? 10 to the power minus 5. So this is 3, 2 more. So you can write student, this is rho 2 19.30. 1 minus 0.00, 5 decimal beta. This is 0.0. What you can say, this is 29. So further students, you can say rho 2 visible na? Yes, fine. Rho 2 beta is 1 minus, you can say 1.1234. So this is 0.0029. How much will get beta? How much will get here? This is you can say 9.1927. This is what beta is 9. So you will get 19.30, 0.9971. You know why I'm doing this calculations? Because you have to avoid to use calculator. Don't be afraid with calculator during calculations. Try to evolve your mind for calculation as well. Now student, further you can solve here further, and I can see beta. So rho 2 you will get, this is approximate 19.24. This is as usual gram per centimeter cube, right? So this is answer of this question. So stay connected students, right? I can see this one, it's a emotion of I can see teacher, emotion of parents, teachers, my friends, family, and all of you, right? So stay connected. Here is a everything I'm going I wanted to will curated content. Okay, now students, we finished only one topic. What's the effect of temperature on density? Now student, I wanted to discuss effect of pressure on density. Okay, so now students, take a snapshot. I want you to turn the page. Okay, so what's the next topic students? Effect of pressure, students, effect of students pressure on density, right my dear? Okay, students, as pressure, as you know everyone, pressure temperature increases, so length increases, area increases, volume increases, density decreases. Here students, pressure is what? Increased. Pressure is increased. Then beta you can say volume is decreases. Pressure is increased, so volume is decreases, right? Hence, if volume decreases, it's a reciprocal to each other, density and volume. Hence, you can write density increases because density inversely proportional to volume, right, my dear? Okay. Now, students, I'll use this formula further derivation. So, students, here I can write density is student inversely proportional to volume. Therefore, you can write rho 2 upon rho 1 is equals to v1 over v2. You know how it came in previous slides. Now, students, you can say rho 2 upon rho 1. It's v1 is nothing but v1 is nothing but it's v only. So you can write v upon v plus dv. Students, here I wrote v2 is equals to v plus dv. v plus dv. Right, student? I can say, my dear, for this condition, what's the point? Students, I want you to use, just I'll take v common from here. From where I want? Denominator. So I can write rho 2 by rho 1 is equals to 1 upon 1 plus dv by v. Right, my dear? Students, now I'm going to use concept of, students, I'm using concept of bulk modulus. Right, so what, students, you can these things already I said recently in the class. I can say mechanics of solid. So students, you can write bulk modulus beta, which is equals to minus dp dv by v. So students, here you can write, because db is to find dv by v, right? Students, here you can write, this is the condition, what we testing, this is dv is equals to minus times v dp upon beta, right? So students, dv by v, what we can say, because dv is to find this one. So you can write, my dear, dv by v is equals to minus times what, my dear, dp upon beta. Students, I'll use this result in these equations. So keep in your mind, online class I'll be go slow only so that you can understand me, right? It's not a physical class. So just student, dv by v already I found this value, I'll fit over here. So now, students, again you can take snapshot. I want you to turn the page. I'm giving you 5 seconds. You can take, then I'll turn the page. Okay, maybe you done. Good. Now, students, I can say this is rho 2 by rho 1 is equals to 1 upon 1. dv by v is what? Minus dp by beta. Right, students? This entire terms, students, here you can see. Here you can see, my dear, dp is what? dp is what, my dear? This is change in pressure. And beta is what, my dear? This is bulk modulus of elasticity of the liquid, right, students? Students, here just I'm going to apply little basics in rho 2 upon rho 1. Student, this entire terms I'm going to take in up. So what you can say, 1 into 1 minus dp upon beta to the power minus 1 only. Students, here again I'm going to apply what concept of binomial. So using concept of binomial expansion, 1 minus x to the power minus in student. This is 1 plus nx. Students, I'll use this binomial expansion formula here. So I can write above expression in this expression rho 2 by rho 1, 1 into 1 plus dp upon beta. Right, students, we got finally expression of this. Now students, just to cross multiply, you can write rho 2 is equals to rho 1 plus rho 1 into dp, and what my dear, this is bulk modulus. So students, you can also write like this, or you can do further manipulation. You can take this rho 1 this side, so you can say my dear rho 2 minus rho 1 is equals to rho 1, this is dp upon what my dear, bulk modulus. So rho 2 minus rho 1 is what my dear, you can say this is delta rho. What my dear, this is delta rho, which is equals to rho 1 into this is what my dear, dp upon beta. This expression also you can use density. What's the heading? Effect of pressure on density. You can also use like this, students, or you can rewrite this same expression. What my dear, delta rho is equals to rho 1 is nothing but, students, here I'm considering rho only, and dp is nothing but, students, this is delta p. So you can write delta p upon what my dear, this is the beta. So this is all about lectures 2. In lectures 2 majorly I explained the theory. Now I'll upload very soon lecture 3. So this is all about. Is there any doubt in entire lecture? You can write your problem, concern in comment box. If I'll back to you as soon as possible. So this is all about today class.